As we look at examples 4 and 5, we can see that once again we're going to find domain and range using interval notation. But one thing we might notice as we look at both examples carefully is that although there's a square root, there's something unique. The x is squared. In one case it is after a subtraction sign, in the other case it's before a subtraction sign. So because the x is squared, it is not a simple square root function as our parent function. So instead we're going to have to use our additional flashcards and look at a new function for us as of now. So what I want to notice is that the number, the constant, is first, and that the variable is second in our first example for example 4. So what that means is that we kind of already have a clue that we have a semicircle because the equation is matching our flashcard. So then we can see that c squared is 4, which would mean that c has a possibility of being 2 or negative 2. So if we think about that, we know those values are probably important in the graph in some way. So if we look and we evaluate using a 2 for x, we can figure out that our y value would be 0 because 2 squared would be 4, 4 minus 4 is 0. If we put in a negative 2 and we square it, we also get a positive 4, 4 minus 4 is 0. And so we see that we have these 2 points. In addition to that, we might try a value in between them. So let's try 0. If we put 0 in for x and evaluate, 0 squared is 0, and the square root of 4 is 2. And that leads us to seeing that we have a semicircle. And if we compare that to the flashcard, we can see the semicircle as well. We can also see that it says you'll go up the value of c, right c, and left the value of c as well. So now, as we consider domain and range, we want to go back and just really think about, are there any arrows on this graph? Is there any unbounded nature? And I would say no. In fact, I see a starting value at negative 2 and an ending value at positive 2 from left to right. And from a range standpoint, I see a lowest value at 0 and a highest value at 2. And because all of those values are included, we have brackets. Now, as we get ready to look at example 5, hopefully you notice that the order of the terms has changed. In example 4, it was 4 minus x squared, whereas in example 5, that order has changed. And so as we look at our flashcard for a semi-hyperbola, we see that the order has also changed, x squared minus c squared. So I'm careful and I'll substitute in 2 and negative 2 again. But if I try to put in a 0, 0 squared minus 4, I end up with the square root of a negative. And we know that the square root of a negative is undefined. So there is not a value in here. In fact, there's a gap. What instead happens is that this becomes what we call a semi-hyperbola, so it's half a hyperbola. Hyperbola has 2 branches, and they're just going to kind of point outwards. We could graph more accurate points, but for our purpose, this graph is sufficient. And then we can compare it to our flashcards showing us that general shape, and also the back of our flashcard reminding us of the actual points. From C0, that it's undefined in between, and now we just need to find the domain and the range. So as I look, I definitely see a gap here in between the 2 branches of the semi-hyperbola. So what I notice is that there are points to the left of negative 2, and then there are more points to the right of positive 2. Now I know that those arrows for left and right will use an unbounded nature for my infinity symbols. And similarly, when I think about the range, I notice that the range for the left branch and the range for the right branch is the same. So I do not need to write it twice. I just start with the lowest value of 0, using a bracket since it's included, and go up to infinity because they're the points above, using a parenthesis. And my domain and range are complete.